So examples for inverse functions. Okay, so the first couple examples, we're just going to investigate the different properties of inverse functions and find inverse functions before we get into the main concept that you need to know their slopes are reciprocals of each other. All right, so it says for this first one, example number 1, find the inverse for this function f of x, which is the square root of 2x minus 3. All right, so this is saying the same thing as y equals the square root of 2x minus 3. So if I want to find the inverse, then I'm going to switch my x's and y's. So I'm going to change my color, x equals the square root of 2y minus 3. So now I'm going to solve for y. So I'm going to square both sides. So x squared equals 2y minus 3. Then I'm going to add the 3 over. So x squared plus 3 equals 2y. And then divide by 2. So that means x squared plus 3 divided by 2, that equals y. So my inverse function is x squared plus 3 divided by 2. This is my answer. So the inverse function of this function we started with is x squared plus 3 divided by 2. Now, it's really just doing the operations in the opposite operation in the reverse order. So if I look at what this x is doing, what's happening to this x? Well, it was multiplied by 2 first, then they subtracted 3, then they took the square root, okay? So if I want to find my inverse, I have to do the opposite operation in the reverse order, okay? So the opposite of square root would be squaring, so I have to square it first. Then the opposite of minus and 3 would be adding 3. And then the opposite of multiplying by 2 would be dividing by 2. So notice that's exactly what's happening here to our x. It's being squared first, then they added 3, and then it's divided by 2. So to find an inverse, you just have to do the reverse operations in the reverse order. Do the opposite operation in the reverse order. The easiest way to do that is just to switch your x and y. All right, number 2. All right, find the inverse of this function. All right, so again, example number 2. This is the same as y equals x cubed minus 1. So to find my inverse, I'm going to switch my domain and range. So I'm going to say x equals y cubed minus 1. So now I'm going to solve for y. So I'm going to add the 1 over here. And then to solve for y, I'm going to take the cube root. So that means y is going to equal the cube root of x plus 1. All right? So the inverse function is the cube root of x plus 1. All right, notice again what was done to x here. It was cubed first, then it was subtract 1. So if I do the opposite operation in the reverse order, I'm going to add 1, and then I'm going to take the cube root. And that's exactly what this is. X gets added 1, and then we take the cube root. And so this is my inverse function. All right, now then it says to graph both of them. All right, so let's take a look here. So x cubed is that sideways x, S shape. And then if we minus 1, it just shifts down to negative 1. So that would be a graph that looks like this. All right, so there is x cubed minus 1. So now I want to graph the inverse. Well, think about what do I know about my inverse. I know my inverse, they are symmetrical across the diagonal line here. So that's what I'm going to do. I'm going to draw a function symmetrical across this line. So I'm just going to do the symmetry here. So I'm just doing a mirror image across this line. So basically I have another sideways S over here at negative 1 is basically what I've got. So it's nice and symmetrical across this line, y equals x. So if you put this in your graphing calculator, if you do the cube root of x plus 1, you're going to get this sideways S here that intersects at negative 1. And it's a mirror image across this line here, y equals x from x cubed minus 1. And I knew what x cubed looks like, and I just shifted it down 1 unit. All right? And so that just verifies that inverses are symmetrical across this line, y equals x, not y equals 1. Sorry about that. They're symmetrical across the line, y equals x. Number 3, find the inverse of this function. All right, so the easiest way, remember this is the same as y equals. So what I'm going to do is I'm just going to swap the letters. All right, I'm going to do x equals, and then I'm going to have y plus 2 over y. All right, so now I'm going to solve for y. So first thing I'm going to do is I'm going to multiply this y over here. So that's going to be x times y equals y plus 2. Now I'm going to minus this y over. So xy minus y equals 2. And now I'm going to factor out the y so that I only have one y. So that'll leave me x minus 1 equals 2. And now I'm going to solve for y by dividing by x minus 1. So y equals 2 divided by x minus 1. So my inverse function here is going to be 2 divided by x minus 1. Now, it's a little harder to do that little strategy that I was talking about where you see what was done to x because this had multiple variables in it. So the easiest way to do it is to just switch the x and y and then solve for y, which is what I did. And I got 2 divided by x minus 1. So that's our inverse of that function. All right, for number 4, show that the slopes of f and f inverse are reciprocals at the mirror points. All right, so we know this is f of x is x squared, so that's the 0.39. So if you put a 3 in there, you're going to get a 9 answer. And then the inverse is the square root function. So if we put a 9 in there, we're going to get the answer 3. So what we want to do is we want to show that the slopes, which are the derivatives, we want to show that the slopes at these points are reciprocals of each other. Okay, just the property that I was telling you. All right, so f prime is 2x. So if we take the derivative of f, we get 2x. So I'm going to plug in the 0.39. So I'm just going to plug in a 3. So f prime of 3 gives me the answer 6. So we should expect the slope of the inverse to be the reciprocal of this. So I'm expecting the slope of the inverse at the value of 9, I'm expecting that answer to be 1/6. All right, so let's show that that's true. All right, so we first have to do the derivative. So this is x to the 1/2. So I'm going to take the derivative. So f inverse's derivative is going to be multiply the 1/2 to the front, subtract 1 gives me x to the negative 1/2, which means this can be written as 1/2 square root x. Because that just means a square root moved to the bottom, okay? 1/2 is a square root, negative means move it to the bottom. So now I want to plug in 9 into this answer. So I'm going to do f inverse's derivative. I'm going to plug in a 6. So this is 1/2. Oh no, I'm plugging in a 9. Sorry, I was getting ahead of myself. So I'm plugging in a 9. So plugging in my x-coordinates. So 1/2 square root of 9. So the square root of 9 is 3. 1/2 times 3 would be 1/6. So it's exactly what I was expecting it to be. We're showing that the original function's slope at 3,9 is 6, and the inverse's slope at the 0.93 is 1/6, and those are reciprocals of each other. So that is the concept that you need to know about inverse functions, is that the slope of the tangent lines at mirror points are reciprocals of each other. I can't say that enough times. All right? So number 5 here. Show that the slopes of f and f, these are already f and f inverse, are reciprocals at the indicated points. So these derivatives are going to be a little bit harder to do, but let's trudge through it. Let's do it. All right, so the derivative of this one, we'll just do ho-de-hi. So we're going to do ho d-hi, which is 0, minus hi d-ho over ho-ho. All right, so there's my derivative. So this is all 0 right here, and get rid of it. So now let's plug in 1. So that's the point we're going to do. So f prime of 1. So if I put a 1 in here, that's going to give me -8. I put a 1 in here, that's going to be 2 squared. That'll be 4. So that answer is -2. So the slope of the tangent line at 1 for the function, the slope of the tangent line is -2. All right, so now let's do the inverse, so the derivative here. So his derivative, okay, might be a little funky here, but let's do it. So let's see, we're going to do f inverse prime of x. So I'm going to do his derivative. So I'm going to think of this as, I'm going to think of it as 4 over x minus 1. Because I'm splitting this into 2 parts, 4 over x minus x over x, so 4 over x minus 1, and this is raised to the 1/2 power. All right, so I just simplified this as 2 different fractions, 4 over x minus x over x, so 4 over x minus 1, raised to the 1/2 power. So now I'm going to take his derivative. So I'm going to multiply 1/2 to the front. All right, then I've got 4 over x minus 1, going to subtract a power. Okay, so that'd be a minus 1/2. And then I have to chain on the derivative of the inside. So I have to chain on the derivative of 4 over x minus 1. Well, the derivative of the minus 1 is 0. It goes away. So I'm just doing the derivative of the 4 over x. So if you remember, 4 over x can be written as 4x to the -1. So I want his derivative. So that's going to be -4x to the -2. So I'm just taking the derivative of 4 over x. Think of it as 4x to the -1. So his derivative is going to be -4x to the -2. Okay? Now you can clean this up a little bit so that we've got, this means a square root in the denominator. So this is going to be 1. Well, it's going to be multiplied by -4. So it's going to be -4. And then there's going to be a 2 in the bottom. This is a square root in the bottom. So there's a square root of 4 over x minus 1. And then this x to the -2 is going to be an x squared in the bottom. All right. So I'm left with the -4 in the numerator. Okay. So that is my derivative of my inverse. So now I'm evaluating that at its point. So I'm going to plug a 2 in here. All right. So I'm going to do f inverse prime of 2. So I'm going to plug a 2 in here. All right, so what am I getting? I'm going to get -4, and then this is 2 square root of, I'm putting a 2 in here, so 4 over 2 is 2, minus 1 is 1, so that'd be square root of 1. And then x squared is going to be 2 squared, to be times by 4. So what's this going to give us? This is going to give us -4 over 8. So -4 over 8, because that's just square root of 1 is just 1. So -4 over 8, that's going to be -1/2. Notice that is the reciprocal of -2. So -2 is reciprocal. Put that over 1, right? Flip that over, you got -1/2. So we're just showing that if you take the derivative of your inverse and you evaluate it at mirror points, the slopes always turn out to be reciprocals of each other. So why is that helpful? Okay, so let's do problem 6. Okay, so this is where we've been trying to get this whole time. I want to find the derivative of the inverse at the value of a right here. So I want to know what is f inverse's derivative at 6. That's what I want to know. That's the question I'm trying to answer. So that's what I want to know. What is the derivative of the inverse evaluated at a, which a is 6? Okay, thing to keep in mind. That means that's the x coordinate for my inverse. So if this is the x coordinate, A is 6, goes here. That's my x coordinate for my inverse. So that means over here on the function, it's the y coordinate. So I need to find my x coordinate. So we're going to set this equal to 6. So we're going to say x cubed minus 4 over x has to equal 6. So this right here is the x coordinate for the inverse. So that means it's the y coordinate for my function f. It's a y value. So I need to find my x coordinate that gives me the answer 6. So I'm setting this function x cubed minus 4 over x equals 6 and finding what x is going to equal. Okay? Well, and this is not anything that I'm going to like do any magical anything with, okay? This actually works out great as far as you can just eyeball it. Okay? If you put a 2 in there, you're going to get 6. Okay? So 2 cubed minus 4 over 2 equals 6. So that's 8 minus 2, that's 6. So x equals 2. It's not something we have to do a whole bunch of algebra on. Okay? We don't have to do a lot of algebra on it. So x is 2. Pretty easy just to figure out. Okay? So that means the x coordinate for my function is 2, which means over here the y coordinate's 2. No big deal. All right? So what do I know about the relationship between the slopes of these two functions, the function and its inverse? Well, I know their slopes at the mirror points 2, 6, and 6, 2. I know the slopes of their tangent lines are reciprocals of each other. Okay, they're reciprocals. So why don't I find the slope for f at 2 and then just take that answer and turn it upside down? So that's what I'm going to do. All right, since I now know my x coordinate is 2, I can find the derivative f prime, which that's going to be 3x squared, and the derivative of that, remember this is 4x to the negative 1, so that's going to be positive 4 over x squared. Just taking the derivative of 4 over x, remember 4 over x is the same as 4x to the negative 1, so his derivative is going to be negative 4x to the negative 2. So his derivative is 4 over x squared, and we're subtracting. So, no, it's negative 4 over x squared, and we're subtracting, so that's why it becomes positive. Okay? All right, so that's my derivative of this function. So let's evaluate it at this x value that we just found. So f prime of 2 is going to be 3 times 2 squared plus 4 over 2 squared. So that's 12 plus 4 over 4 is 1, so that's 13. So the slope of our function at 2 is 13. So what does that mean the slope of our inverse is at 6? Well, his is going to be the reciprocal. So the answer is going to be 1 over 13. Notice I did not have to find the inverse function to figure out the answer. That's the whole point of what we're learning about. You don't have to find the inverse function to figure out the slope of its tangent line. You can find the slope of the tangent line on the function and then just do the reciprocal. So our slope of f prime at 2, so the slope of this function f at 2, its slope was 13. Okay? So that means the slope, the derivative of the inverse at 6 is the reciprocal of that. So it's 1 over 13. Okay? So the trick was this is the x coordinate for my inverse, but this is the y coordinate for my function. All right? So this is my f of x. All right? So that's why we set this function equal to 6, because it's our y value for the function. It's the x coordinate over here for the inverse. So last one, do one more. Okay, same thing. I want the value of f inverse's derivative at the a value, and our a value is 2. So that means that's the x coordinate. That's the x coordinate for our inverse, which means over here it's the y coordinate for the function. So I'm going to set this function equal to 2 to find my x value. So now I'm going to square both sides. So 4 equals x minus 4. So then when I add 4, I get 8. So when you put an 8 in here, 8 minus 4 is 4. Square root of 4 is 2. So this is 8. So that's the x coordinate here, which means it's the y coordinate over here. Okay. Now, I want to find the slope, which is the derivative of the inverse at 2. But I don't know the function, and I don't want to take the time to find the inverse function. But I'm just going to use the function I'm given. Now that I know the mirror point is 8, 2, I'm going to find the derivative of this function and evaluate it at 8. Then I'm going to take that answer and just do the reciprocal. All right? So I'm going to do the derivative of this function. So f prime of x. So remember, this is x minus 4 to the 1/2 power. So that's going to be 1/2 x minus 4 to the negative 1/2. And then if you were to chain, it would just be a 1. So that's, make sure we're not forgetting that. All right, so that means my answer is 1 over 2 square root x minus 4. That's my derivative. All right, because that's a square root. 1/2 is a square root. The negative means put it in the denominator. All right, so I took the derivative of this function, and I'm going to evaluate it at my x coordinate that I found. Okay, because I set it equal to this y value to find the x coordinate so I could use it. So now what is f prime of 8? So we're going to put 8 in here. So 1 over 2 square root of 8 minus 4. So 8 minus 4 is 4. Square root of 4 is 2. 2 times 2 is 4. So this is a 1/4. So what is the slope of the inverse at 2? Well, it's got to be the reciprocal of this, so that means the answer is 4. Notice we never did find the inverse. You don't have to spend the time finding the inverse. I just did that earlier to show you, to remind you what inverse functions are, just by making us find some. But we don't have to find the inverse to find the slope of the tangent line at the mirror point. They are reciprocals of each other. So just remember this value that they gave me, that they wanted me to evaluate the inverse's derivative for. It's the x coordinate for the derivative. It's the y coordinate for the function. So that's why we set the function equal to that number. I squared both sides. All right, this was a 4. I squared both sides, and then I added 4 to get the answer 8. So that's my x coordinate to go with this function. So I found his derivative. I evaluated it at 8. His slope is 1/4. So that means the inverse's slope evaluated at 2 is going to be the reciprocal of that, which is 4. And we did that without finding the inverse function at all. So the only concept you need to make sure you know about inverse functions for the AP exam is that at the mirror points, like here 2, 8 and 8, 2, at reciprocal points, the slopes of the tangent lines are reciprocals. That's all it is. They are reciprocals. All right. The last problem, which is not related to anything as far as it's not related to inverse functions. This is just a problem thrown in because I think it's in your assignment, one similar to it. Find the derivative at the indicated point. So we want the derivative of this thing. All right, so we just want to review derivative. So I'm just going to do implicit differentiation. So the derivative of x is 1. On this side, I keep my coefficient 2. I'm going to take the derivative of natural log. Remember, derivative of natural log is the derivative of the expression. So that's going to be 2y dy dx. You got to remember to chain since I'm taking the derivative of the y. So 2y dy dx divided by the function itself, y squared minus 3. Okay? So that's the derivative of this expression. Now I want to evaluate it. And well, we can solve for dy dx if we want to. So let's see, or we can put the point in first. It's whatever you want to do first. So if I wanted to multiply the y squared minus 3 over here, I would have y squared minus 3 equals 4y dy dx. So if I actually found what the derivative was, I would have y squared minus 3 divided by 4y. All right. So now I want to find the value of the derivative at the point 0, 4. Notice I've just got y values here. So dy dx, I'm just going to plug in the y coordinate, which is a 4. So this is going to be 4 squared minus 3 over 4 times 4. So 16 minus 3 is 13, and over 4 times 4 is 16. So there's the slope of the derivative at the indicated point. Now, we could have plugged the numbers in here, like I could have put 4 in here and then done the math, but I still would have gotten 13/16 as my final answer. All right, so that is just using implicit differentiation. Also reminding how to do derivatives of natural log. It's the derivative of the function over the function, and here we were just taking the derivative of a y, so we had to chain on the dy dx, which is really what you're solving for when you're trying to find your derivative. And then you're plugging in the 0.04 to find the actual slope of the tangent line at that point. All right, so that was just practice doing that again. Okay, so here are your assignments on page 338. The main thing you need to remember is that for reciprocal or mirror points, a function and its inverse, the tangent lines have reciprocal slopes.